Hello everyone, welcome back to iNeuronics.ai. So have you ever wondered how companies handle incorrectly oriented images when user upload documents or IDs during onboarding? Imagine thousands of user uploading images with a random orientation, top down, sideways or even upside down. Correcting all of these manually, no way. So today we are diving into how we can build an image orientation correction framework using machine learning to automate this process. Sounds exciting? Let's get started. So first of all, we talk about real world context in the problem explanation. Picture this, you are onboarding a customer in a fintech app. They are required to upload a government ID or a document. It can be Aadhaar card, PAN card, passport, etc. But wait, many users accidentally upload their images sideways or upside down. It means images with wrong orientations. What happens next? Then manual intervention will come. A human operator has to correct the orientation before processing it, and when there are thousands of such uploads daily, this manual task becomes tedious and expensive. Wouldn't it be awesome if we could automate this particular process? Yes, we can automate this particular process with the help of AI powered orientation correction framework. So now we'll see the step-by-step framework that we're gonna use for implementing or for solving this particular use case, we can say. So our goal is simple: predict the correct orientation of an uploaded image and rotate it automatically to a standard position. Let's call it a horizontal down. For example, regardless of how the image is uploaded, top down, left or right, it'll end up properly aligned, and we'll make this happen using a combination of machine learning and image processing tools like OpenCV. So first of all, we need to collect the data set. We need a diverse data with images in different orientation: horizontal down, or we can say the images in correct orientation; horizontal top, or we can say upside down; vertical left, or we can say rotated left; a vertical right, or we can say rotated right. For this demo, we'll collect around 500 images per class, making sure to cover various document types like ID cards, receipts, or any onboarding related images. But for this particular example, we are considering the passport only. And as per your use case, you can consider any data for fine tuning the models that we will do in the further live demo. So have a look on the training the model using Swin Transformer. To classify these images into the right orientation, we'll use a Swin Transformer model, which is a cutting edge computer vision model available on Hugging Face. Now question arises, why Swin Transformer? Because it's great at capturing hierarchical features and works incredibly well on image classification task. So we'll train the model on a labeled data set. The training involves feeding the images and their orientation labels into the model, allowing it to learn patterns that differentiate each class. Once trained, we'll push the model to the Hugging Face hub, so it is accessible to everyone. And once the model is trained and deployed, the fun begins. Every time a user uploads an image during onboarding, the model predicts its orientation class, whether it is upside down, sideways, or already in the correct position. So after that, we'll use OpenCV to rotate the image based on the model prediction. OpenCV is a powerful image processing library. For example, if the model predicts vertical left, we'll rotate the image 90-degree clockwise to make it horizontal down. So in this way, we'll solve this particular use case. Let's have a look on the live demo. First of all, I would like to show you how I have collected the data set, or we can say in which format I have collected the data set. So what I did, I have collected the images of the passport in 4 different classes, as I mentioned inside the presentation: correct orientation, rotated left, rotated right, upside down. So if I open this particular folder, as you can see over here, I have a passport with correct orientation. So if I open rotated left over here, the passport is rotated in the left scenario, right? So it is an incorrect orientation. Similarly, we have a rotated right, and similarly we have upside down, which is like that. So I have created a directory using all these 4 classes, having around 500 images for each one of them. Again, you can select n number of images as per your use case. And so I have uploaded the folder on Google Drive, which I'll access using a Google Colab notebook that I'll show you in future demo. Now we'll see how we'll train the image classification model for predicting the class of the orientation. So before diving into this particular notebook, I just want to explain how I get this particular notebook. So what I did, I have opened, Hugging Face notebooks like that. Cool. So over here, I have a task called as how to fine tune a modern image classification. So over here, I have a collab notebook. So I've taken this particular notebook and now we came over here. So the name of the model is Swin and it is given by the Microsoft. And so we are over here, we are installing the requirements. We are installing dataset library, transformers and accelerate library. So then over here, what we will do. So here we'll pass the access token that we have created inside the first video. And then we'll install all these requirements and then we'll import some of the things at elementary, and then we are mounting this particular Google Colab with a Google Drive, and then from the Google Drive we are fetching this particular folder called as final data, which I have showed you, this one, right? So then we are running the entire notebook cell by cell, as you can see. Guys, this particular code is self-explanatory. We have comments for each and everything. You can read all these things to become familiar with each and everything. So, and then over here we have image processor from transformers library, and then over here we are applying the data augmentation. Data augmentation, it means we are increasing this number of images with a different zooming, different sharing and all. And then we are splitting the data set into training set and testing set to avoid the problem of overfitting. And uh, okay, so then we are training the model. We are running the notebook cell by cell. So these are the parameters. So we are running this particular model for 5 epochs. This is the name of the model that would be there on the Hugging Face hub. So we are running the cells, and then we are using the trainer class to fine tune this particular model. So I got an accuracy of 97%. Then using this particular code, I have post the data, I mean to say the fine tuned model on the Hugging Face. So as you can see, this is my Hugging Face, and this is a trained model. Here I have accuracy of 97% and loss of 0.01. So now I'll load this particular model to test it whether it is working as expected or not. So I'm loading this particular model. The model is loaded. I've taken this particular image. As you can see, this is a image with a correct orientation. So I've taken this particular name from the directory. This is in correct orientation. Now I'm taking this particular image, test2.jpg. As you can see, this particular image is not in the correct orientation. So that's why I'm taking this name. Cool, it is rotated right. So our model is performing very well. Now we'll see how we can rotate all these images using OpenCV to bring them in correct orientation. And now we'll see how to rotate the image at the end using OpenCV. So first of all, we need to import some of the packages like cv2 numpy request below operating system and IO. And then after that, we'll write a function to rotate the image based on the orientation as discussed in the slides. So if the orientation is rotated left, we'll rotate it by 90 degree. If it is upside down, we'll rotate it 180 degrees. And if the orientation is rotated right, then we'll rotate it by 90 degree again, but in anti-clockwise direction. Anti-clockwise direction. And if the image is in correct orientation, then it means all set. Then we'll write a function for getting the orientation. There's a function for getting the orientation of the model. And basically this one is used for dealing with the models that we have trained, right? And then we'll write a function for loading image from a URL or a local path. This is a function for loading the image from URL or local path. And then we'll correct the orientation and save the model in a directory as discussed. So here is a code for that. And then we'll call this simply. Just give me a second. Yeah. So let me show how this work in a practical scenario. First of all, we are taking this particular image as an input. This is the image, which is an upside down orientation. So our model should first of all predict that it should be in upside down orientation, and inside this particular directory called as output, it should be in correct orientation. So I'm running the code. So as you can see, with 99% threshold, my model is saying it is upside down. And here you can see we have a corrected image. Which is in correct orientation. This image we have given as an input, and this is the corrected one. So this framework isn't just for fintech. Think about other industries: healthcare, e-commerce, education. In healthcare, we can have a patient documents, uploads for the digital healthcare records. In e-commerce, product images are displayed correctly on seller platforms. It should be there. In education, we can use this one for assignments or documents in online submission portals. The possibilities are endless when you combine machine learning with the practical use cases. That's how you can build an AI powered image orientation correction system from scratch. If you found this helpful, then please share this particular video. I'll see you in the next one.